It sounds like we're recording. So before we move on, I will review. Apologize for not showing the first part. But the first question was something about how do you know things are congruent? Is it the sides? Is it the angles? Is it this or that? Or is it both? Okay, for congruent, it's got to be both. The angles got to be the same. The side lengths have to be the same. Okay, that's what it means for congruent. Same shape, same size. It's the same shape because the angles form the same degree measurement. Okay, this question number two. This question two, they give us this drawing, and I labeled it exactly how they gave it to me labeled. And then they gave me this triangle statement here that said triangle ABD is congruent to something, and they wanted us to solve for that something. Okay, what letter combination is it? And so what I did, right, I took this left side triangle and I copied it down. I put A on top and then put B to the right of it and then D to the left of that. So A, B, D. And I drew down, or I drew just the little top and left side. Okay, just because that should be enough, since I know that the angles are going to be the same, but that should be enough, right? With the from A to B is the one mark they gave us, and A to D is the little double mark they gave us. So A to B is the single mark, A to D is the double mark. And then I look at this one, and I notice that A and C have the same angle measurements. Maybe I'll kind of draw that out. But those have the same angle measurement, just like that's got the same angle measurement. Okay, so that's going to go on top. So that means I'm going to put this on top. And I'm trying to notice like the rotation of letters. Like, is it CBD? Is it CDB? Like, what's the order they want us? So trying to copy this one, right? I saw the little one single mark here. So I'm looking on this other little weird triangle. I'm kind of investigating. Where's that little single mark at? It's right there between C and D. Well, I know C is on top, so that's going to force D to be on the bottom right for this triangle. And then I look at the little double marks, okay? The double marks here are between A and D, right? And so the double marks of this one are between C and B. So between C and B, there's little double marks, okay? I could fill in the other angles, okay? But there's really no need to, I think, at this point. Hopefully you guys can understand how it's all labeled. So after I finished writing that out, I noticed the one that the statement they gave us said go from A, B to D. So those three vertex points in order. A, B, D. So following that same pattern, C, D, B is what that statement has to be. Okay, if you do any other order, it's going to kind of mess things up. Okay. So when you're given like some sort of statement that this triangle is congruent to this triangle or this shape is congruent to this shape, just know the order they wrote the letters mattered. Okay, usually the first one doesn't really matter. You get to kind of decide. But the second statement has to follow the same or relative vertex points. So A is like C, B is like D, and D is like B for those two shapes. Okay. All right. So let's move on to the next question. No questions? Okay, let's move on.
Can you go to question 5?
I'm sorry?
Can you go to question 5?
Hey, Brian, I'm going in order, and when I get there, I get there. If you have, if I understand that if you're already there, that's cool. But some people didn't even start today; they had some issues, whatever. So I'm going to go ahead and I'm going to just keep powering through till we get to 5. Okay. So just for the sake of everybody in class, I'm going to go through each and every question just best I can. Okay. So I appreciate your patience. If for some reason I can't answer it during that time, just email me and we'll work on the individual notes. But I should be there in just a little bit. Okay. Okay, so we're on question 3, which is very similar. So I think we can go through this one a little bit faster. So question 3 looks very similar. This time, however, we have 2 triangles that face each other. So it looks kind of like a bow tie. So I'm going to go ahead and, you know what? Where is my, here it is. Ugh. All right, so let's go ahead and let's write this like this to this. Let's go out a bit and go from here to here. Connect these pieces. Connect those pieces. All right. So then what do we have? We got A, B, C, D, E, and it goes in this kind of order here. A, B, C, D, E. And now on the outside is those little marks. And then the double marks go here. The double marks go up there. The triple marks are here. The triple marks are here. single angle, or the single little mark on that angle, single little mark on that angle. The double mark here. Now, I remember a while ago, we talked about vertical angles, where whenever you have like lines that cross, the opposite angles are always the same. So no matter how the lines cross, the opposite angles are always congruent. So you could put this here. It's implied that they're the same. Okay, that if that was 20 degrees, that'd be 20 degrees. If that was 30 degrees, that would be 30 degrees. Okay, that was one of those concepts we talked about last semester, and it's all kind of hopefully coming this semester, as far as we're just using it more than we were last semester. All right, so I'm going to go ahead and I'm going to kind of copy down these triangles, and I'm going to try to write them just like the last time. I'm going to write them in the same order. So this is what I mean by having scratch paper out as you work through these, because sometimes doing them in your head, even me, I've been doing this stuff for a billion years, and I still got to copy it down just to make sure that I'm doing it correctly. So before I get started on this, I'm going to look at the statement they gave me, which said triangle ABC is congruent to what? That's what we're trying to figure out. I know it's going to be triangle something, but I'm trying to figure that part out, okay? So I'm going to go ahead, for the sake of this question, like the last question, I'm going to put the A on top. So someone's got a question. I heard a little beep, and it says, Ricky says he has to go. Okay. Well, Ricky, you can always double check this stuff later. I'm going to go through everything here. So I'm going to put the little A on top. And I'm just going to go, you know what? I'm going to go, that's fine. I'm going to go in this order here. I'm going to make it look, I'm just going to turn this like this. Okay, so it goes A, B, C this way. So it goes A, and then B is going to go to the left, and then C is going to go to the right. So B is going to go there, and C is going to go there. I'm going to, once again, between A and B has a little mark, and between A and C has that triple mark. Okay, and then between B and C is the double mark there. So I understand the angles are going to be the same. I'm just going to copy the side lengths just to make it easier and go faster. So, you know what? At A, I see a little single mark. I think that was probably a good strategy last time. You see, it's got a little single mark on the angle here. The single mark here is going to be where the E is. So I'll put the E on top. And then, you know what? Let's keep doing that. You see where B has a double mark? Where's the double mark on here? That's D. So I'm going to put letter D right there. That's actually probably a pretty good way to look at the vertex point. And then what's on the bottom right? The bottom right here is C. The bottom right there is C. That's the triple mark. And to confirm, between E and D, it should be one mark. Between E and D is one mark. Yep. Between E and C should be a triple mark. So between E and C is a triple mark. Cool. And that means between B and C is the double mark. Between D and C is the double mark. So they go A, B, C, starting on A, but this time going to B and then to C. So I'm going to start at E and then go to D and then to C. So E, D, C. All right. EDC is right here. This should be good. Hit submit, and booyah, we got it. Okay. Okay, I'll give you guys about 30 seconds to a minute, and then we'll get going again. Let's do 30 seconds just for the sake of time. If you guys need to review this video will be available for you sometime later today after it gets uploaded. All right, it's been about 30 minutes, about 30 seconds. So let's get going to the next question. Okay, so the next question says, complete the congruence statement, very similar to the last two. So I think I'll have enough space here. Let's draw a line. Let's go to question 4. And now it's got these two triangles. I'm going to go ahead and just for, like if I was going to do scratch notes on this, this is how I would do it. I'd make my first triangle. And then I'm going to draw this triangle here. It's saying that they're congruent. So I'm going to go ahead and start with that. And let's see. Whoops, that didn't quite work out well, did it? Let's make this longer. Okay. So these triangles they're saying are the same. And this is the little right triangles because they have the right angles. Okay. This left one, they're telling me right now, this left one, okay, is, well, first of all, it says triangle HIJ. So let's copy down HIJ. We're trying to figure out the order to put the letters. So HIJ. So, okay. So this one then, I see the right angle is at M. And then you see how that's got like the little, H is that little, the mark, it's got like little 2 marks here. And I see K is right there. K has the double marks for that picture there. And then the single little mark is J. The single mark here is L. So I'm assuming then, let's take a look. H and I has the double marks. K and M better have it. Yep. They're saying that I and J has a double mark. So what that means, this is kind of a special thing, but they didn't really, I think they messed the picture up and that's okay. But usually when you see double marks in 2 spots like that, that means that this side length and this side length are the same. This side length and that side length are the same. So if this equals 5, that would be 5, 5, 5, 5 all the way across. They might have messed up because of the way the picture looks, but doesn't matter. I'm assuming that it's a single and they kind of messed up, but that's okay. So from L to K, yep, that's the triple mark. So if you see something like this used multiple times, that just means that it's all the same. It's just kind of difficult to see because the picture looks like this, but sometimes I'll draw pictures like this just to kind of mess with you and say, oh, it's not to scale. And it's just, you just got to read the markings and trust that those markings are correct, even if the picture looks wrong, and that's okay. All right, so we're going to go ahead and go to this order here. HIJ, KML. All right, so I'm looking for KML, and that would be the second option for me. Cool. All right, so as before, I'll give you guys about 30 seconds, and we'll move on. As Brian was asking, we'll go ahead and start number 5, and we're done with this one. Doing good on time. All right. Okay, it's been about 30 seconds, so let's go ahead and start number 5. All right. Hey, Brian, can you hear me?
Yeah, I can hear you.
So what specifically about number 5 are you having trouble with? Is it just starting it and kind of understanding the process of it, or is there a certain spot where you feel like you're stuck on it?
I forgot the equation to solve for x on this one.
Oh, yeah. So on something like this, it's not really necessarily a full equation. It's just looking at the picture and kind of seeing what they want us to do with it. So we have 2 shapes, and the fact that they describe it as congruent. So they didn't put the symbol, but they put the word. They said polygon ABCD. So I'm just going to put A, B, C, D. Once again, a polygon just means a shape with multiple sides to it. Okay, so anything a triangle or above is considered a polygon. As long as it's closed and it's not all weird looking, as long as it's any general shape that we're kind of used to seeing in math. All right, so it's congruent. It means we can write that symbol out. It's W, X, Y, Z. So W, X, Y, and Z. Find X, find the length of AB, and find the length of WX. So this is kind of my little answer space when I finish. I'm going to use that to fill in the answers. So as you were saying, Brian, there's some sort of equation. You know there's something to solve for X, which is awesome because that is exactly right. But don't freak out. It's not some crazy equation to remember. Where is, that's the closest looking shape. I'm going to draw it like this. Now watch what I do. I'm going to make this like this, even though it's kind of tilted sideways. I'm going to try to do the same thing as before where remember how they gave us to it like differently, but then I recreated it so it's in the same order. I'm going to do the same exact one with this one. Okay, so once again, if I was doing this problem, this is how I would do it. I wouldn't recreate it twice. That was just kind of for your notes. Okay, and kind of like to, but I think hopefully everyone kind of sees my process. So I'm going to skip that kind of step 0 where I draw out the thing and recreate it perfectly. I'm just going to just draw it right on here. All right, so I'm looking right now. It says A, B, C, D in this order here. A, B, C, D. And they say between A and B is 2x plus 8. So I'm looking for that. So you see how it says A, B, C, D? I'm going to label it in the same order. So once again, I'm going to, they start here and it goes around this way. I'm going to do the same thing here. I'm going to start there and go around that way. So hopefully you're kind of seeing the connection from what I was doing here to how this now applies here when we have some algebra and stuff involved. So A, B, C, D in that order. I'm going to go W, X, Y, well, capital Y, I guess. We're dealing with vertex points. Vertex points are traditionally, in a standard way, written with capital letters. That's vertex points, okay? So I'm looking at my picture. It says between W and X is 4X minus 4. Okay, looking at the picture on my problem, it says between W and X is 4X minus 4. If it was written anywhere else, we probably couldn't do anything with this problem. So I would suggest wherever you see a question like this, they're not doing anything weird and trying to do things that you haven't been taught yet. You see two expressions like that, you're probably going to have to do this process with just what they gave you without having to redraw it. Just, oh, that's got to equal that or something. Okay, so Brian, here's kind of the equation you were asking about. Okay, is because the fact that they're saying they're the same, remember when they're congruent, the side lengths are the same, the angles are the same. So that means that this and this actually represent the same distance, the same length. Okay, so I can say that from A to B is equal to 4x minus 4, which is our wx. So what's kind of cool is when I finish this, whatever I get for one length, I don't got to do it twice. It's going to be the same no matter what. All right, so 2x plus 8 is equal to 4x minus 4. Okay, so that's kind of the equation you were probably looking for, right, Brian? So there's no formula or like, you know, song to learn about this stuff. It's literally if A to B is 2x plus 8, okay, right? A to B is 2x plus 8. That means WX has to be the same piece too because they're in the same location of the way they wrote it, okay? All right, now here's some algebra. I'm going to subtract both sides by 2x. I do that because if I subtracted 4 from the 2, it would give me a negative number, and I don't like dealing with negatives personally. Okay, I'm going to do a quick double check, make sure all my signs are the same, right? 2x plus 8, 4x minus 4, cool. This is where some mistakes can happen where you switch up the signs and stuff. Okay, I'm going to add 4 to both sides. I'm going to add 4 to both sides. So that 8 plus 4 equals to 12. Okay. So the last step here is to divide. 12 divided by 2 equals 6. So that is not my length. Well, it might be, but that's what the value of x is. What they want me to do now is figure out the lengths. So I'm going to do it twice. I'm going to do it with each equation, but I'm telling you now, I'm pretty sure, okay, if we did this correctly, these should equal to the same numbers. That's one way to check your work if you want to just double check your work. If you want to be fast at it, just plug it in once and copy the number down to the other one too. So it says 2x plus 8. I'm going to go ahead and plug in the 6. And that is 12 plus 8, which equals 20. So I'm going to go ahead and write 20 here also because if they're congruent, they should be the same number. But I'm going to go ahead and do this one here. So 4 times 6 minus 4. Okay, 4 times 6 is 24. Take away 4. There's that 20. Cool. All right. Let's do about 15 more seconds. So Brian, did that answer your question? You feel confident with doing it on your question? Let's double check here. This is 6. And we said 20. Whoops. 20. 20. Hit submit. Booyah. Sweet. Okay. Let's do about 20 more seconds or so. Okay. And before we move on, they give you a little note there. It says, always make sure the value of X produces positive lengths. So what they kind of mean by that is they're kind of telling you that the X can be negative or positive. They just want you to make sure to like double check that the number you get, when you plug it in, you should get a positive value for your length. Okay. I think that note there is there like permanently, because you can make this more complex where you have like X to the second power. And a little thing with advanced algebra, if you have something to the second power, you have the possibility of having 2 different answers. If you have a third power, you have the possibility of having 3 different answers. That all work out for the problem, but they might not work out for the geometry because you get a negative number. So in those cases, you get rid of that. But once again, it's more advanced. I think this is kind of like a note for that. Okay. All right. Question 6 looks very, 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 very similar. It's solved the exact same way. Okay, I'm looking right now. I'm just going to take a guess. You see how that says angle C is 13x plus 7. So I'm assuming whatever congruent statement they give me, okay, A, B, C, D, that polygon is going to be wherever C is, that's where, that wherever it is, they're going to be the same angle. So I have A, B, C, D, W, X, Y, Z. Okay. So C and Y are probably going to be the same vertex point when I do my drawing. So for the sake of time, I'm just going to do a quick little guy here and a quick little guy there. So it says A, B, C, D. So on the other shape, which should be the exact same size, this and Y, right, C and Y should be in the same spot. All right. W, X, Y, Z. Let's go in that same order. Okay. Because remember, however they write it, that's how it goes. Okay. So I'm going to do the same thing for this one. There's a purpose in every letter that they wrote for this stuff, right? Sometimes it doesn't really matter in math how they write stuff, but for this case, it's actually part of the process, okay? But they write it in those ways. So for this one, they say C, they want us to find, once again, X. They want us to find the measure of angle BCD, which once again, for the way they write these angles, the middle is always the vertex point, and the letters next to it are the letters around it to kind of show you that in case it's kind of weird looking with a lot of letters and a lot of little angles created at one vertex point, then it matters that you write it out like that. For this case, though, since they're just plain shapes, like, right, I'm thinking like if you've got some shape like this with multiple letters, then it's like really important how you label, your stuff. But for this case, this problem does not look like that. So the 3 letters are just kind of, I guess, extra for this one. And lastly, measure of angle XYZ. Once again, I guess they don't put the degree there. The degree goes on this side. So these should be the same. Okay. All right. So remember I was kind of telling you with the last problem, you can kind of assume that whatever information they gave you, just set it equal to each other and solve for X. Okay. So it says 13x plus 7 here. And 14x minus 1 there. So I'm going to go ahead and say 13x plus 7 is going to equal to 14x minus 1. So let's double check. 13x plus 7. Yep, 14x minus 1. Perfect. Okay. So I'm going to solve for this by subtracting both sides by the 13x to make sure that I keep positive with my x values. Now, when I have 14 minus 13, okay, 14x minus 13x, you have two options here. I'm going to show you the standard way that we do this. But when you have something like 14 minus 13 or something similar where it just equals 1 and you have a letter there, like x, like give your variable, right? In the standard traditional way, we don't write that 1. Okay, you don't put the 1 there. That's just kind of a standard thing that says we just have 1x. Anything more than that, it's you have to put the number. How many x's do you have? In this case, we have 14 for this one and 13 for that one. Right? Not writing the number gives you just 1. Okay. Everything looks good. Positive 7. Yep. Minus 1. So I'm going to add this one to solve for x. And I get 8 equals to x. Okay. Cool. So is that my final answer? Nope. They want me to plug it back in. So I'm thinking right now, let's just use this one on the left, the 13x plus 7. X is going to be equal to 8 plus 7. All right. Here's where Mr. Atterbury doesn't want to make any mistakes. So I'm going to go ahead and do a calculator. I'm going to go ahead and let's find whatever. Let's do 13 times 8. Okay. Don't feel like using a calculator is bad. Calculators are fine, especially when you're trying to not make any mistakes whatsoever. And then adding 7 gives me 111 degrees. So I'm going to make the assumption that this is 111 also. But once again, it's in pencil, so I can erase it if I am wrong. I'm going to go ahead and try out this other equation, 14x minus 1, just to make sure I'm doing everything correct. So I'm assuming 14 times 8 is going to be 112. Let's try it out. 14 times 8, 112. Awesome. Anything else, and I'd be kind of scared. I'd be like, oh, no, I messed up. Cool. I'll keep this up for a minute. If you have any questions about your particular question, I can try to answer it then. Okay. Let's double check our answers. 8. 1, 1, 1, 1. Oh, 1, 1. Yes. About 10 more seconds, and we'll move on to question 7.
I have a question for number 6.
Yes. Sounds
So
like
I did all the steps,
Mhm.
but I think I messed up on the x again because
Okay.
I got 18 equals 5x, and then I divided it by 5,
So
and it gave me 3 point something.
I'm going to double check. Okay. What it sounds like to me is, since these usually deal with just, I try to select problems that don't deal with fractions and decimals just to kind of cover the concept and not necessarily the the full-on crazy stuff with everything. So I'm looking right now. Hold on. Oh, it's showing me as a test student. Hold on. Because I logged in. Hold on 1 second, kiddo. All right. I got to undo some stuff here. All right. Let me refresh this. Let me go like this. All right. Give me 1 second. Okay. So your question says 9x plus 12. You should have had 9x plus 12 equals to 11x minus 6. Is that what you did? Alyssa? So I'm going to go ahead and write out the statement that says 9x plus 12 equals to 11x minus 6. So let me share with you. Georgia says she's finished. Lucas says he's finished. So Lucas and Georgia, oh, they took off. Cool. Okay. That's all I was asking. Okay, so let me double check. Let me show you what I'm looking at here. Window. Jacob took off. Huh. Okay. Hopefully he's got it done too. Okay, so you can see what I'm looking at, Alyssa?
Yes.
So did you? So this is how you wrote it out, right? I'm going to do step by step. I'm going to subtract 9x to both sides. When I do that, I get positive 12 equals to 2x minus 6. Oh, you said you had 5x?
Yeah, I probably subtracted wrong.
Yeah, I'm trying to think. Someone's not happy. Okay, I'm thinking right now, I see 11 minus 6, so maybe you saw this 11 minus 6 and for some reason put 5 there. But I'm thinking right now I'm going to add 6 to both sides, and that would give me a, whoops, I don't know why I crossed it out. That would give me 18 equals to 2x. So I'm thinking right now, you solved for x and just got the incorrect answer for x, and that gave you an incorrect answer for the angle measurements.
Yeah.
So what would you get for x in this case?
9.
Perfect. Dividing by 2 gives me 9 equals to x, which is the same as saying x equals 9. So I'll give you a moment. And now that we know that x equals to 9, for your individual question, why don't you finish that off and solve, right, you're going to plug in 9 back into the other questions, right? Now that we're dealing with angles, a lot of times when you kind of solve for them, you're going to see them anywhere from like 1 degree to 180 degrees. Traditionally more between like 20 and like 100 or so. Like that's usually where a lot of your angles and triangles end up at. All right. So I'll give you about 30 seconds for that, Alyssa. I think you'll get it in that time. In the meantime, let's get back to, let's do the test student again. And then let's go to Zoom. Okay. Okay. Now, when you redo it, you should get the, it should just give you full credit, okay? So if you ever miss a question like that and we're like, everything's kind of wrong, don't feel like you did everything wrong. If you got the X value wrong, that's usually going to make your angles now wrong. Okay, so if you get the X value wrong, that means the angles are wrong. Even if you did everything the right process, but you made a little small error while doing the calculating the X value. Okay, so because you calculated the X value wrong, once again, like I was saying, all right, because you calculated the X value wrong, it's just going to be like a water slide or a waterfall of just like, oh, everything else is not going to be wrong. So if you go back and correct the first part, that'll help you then with the other parts. Okay, so once again, the shortcut, I'm telling you right now, I'm pretty sure, because there's not a lot of information given, I'm pretty sure it's going to be, for my problem for question 7, 6x minus 3 is going to have to equal 5x plus 2. That's kind of like that math student like shortcut kind of brain that I'm thinking of right now. So I'm going to go ahead and write this out as number 7. Let's zoom out a little bit. Let's see what would be the, all right. So I'm going to make the assumption right now before I draw it out, but I will draw it out to show you that 6x minus 3, I'm pretty sure they're going to make that equal to 5x plus 2. I'm pretty sure that's what I'm going to have to write. So I'm going to go ahead and write out the information they gave me. It says triangle ABC is congruent to DEF. They didn't write the symbol, but that's what they wrote the word. We're going to transform that word into a symbol, equal sign with a similar sign on top. Okay. Similar is the squiggle. Okay, so I'm going to go ahead and let's see, that triangle looks sort of like that-ish. Sure, let's just do this one. Okay, so I'm gonna make these triangles look the same. This one says, let's just go A, B, C like this, A, B, C. So that means D, E, F, right? Don't forget, if it goes in this order like this, A, B, C, we're gonna put it in that order like that. And then same thing, D, E, F, it's gotta all go in the same order, okay? So between A and B is 6x minus 3. So between A and B is 6x minus 3, right? Between A and B. So I'm assuming between D and E. Yep, between D and E is 5x plus 2. Between D and E is 5x plus 2. All right, so 6x minus 3. Yep, 5x plus 2. Yeah, that's where I know personally wherever I make mistakes, I always make mistakes by copying down the positive, negative wrong, right? The plus sign and the minus sign. Like I'll make those mistakes. I do my best to double check so I don't make those mistakes, right? That's just one of those things that I've learned, that whenever I make a mistake solving for x, most of the time it's because I made a mistake copying down the problem, okay? Or through the problem, I switch the signs around, okay? So I was right to assume that. Just for space, I'm going to go ahead and recopy it. I kind of feel like it's all crowded right there. Okay, minus, minus, plus, plus. Cool. Like I do those things, okay? I've been doing this for a billion years, and I still do those things because I know I make mistakes. And I found that if I double check before I start or while I'm doing it, that will save me some heartache at the end where it's like I did all this work and then I got to go back and do it again anyways because I made a mistake. So I found by going a little bit slower, checking my work multiple times before I start or while I go, that helps me not have to do a bunch of extra stuff at the end. Okay, so solving this, I'm going to go ahead and subtract 5x to both sides. That's just 1x, remember, just write the 1, or the x by itself. Still minus 3. Once again, I'm double checking that, okay? Positive 2, double checking that. To solve for this, I got to add 3 to both sides. And that makes sense that x equals to 5 for my problem, right? 5 minus 3 is 2, okay? So I feel pretty confident that x equals a positive 5. Let's plug that in to make sure that the answer makes sense. I'm going to do it twice just to check my work. I'm going to say 6x minus 3. But instead of x, I'm going to put 5. So times 5 minus 3. That's 30 minus 3, which equals 27. So that's not an angle measurement. That's a side measurement. So we don't know if it's centimeters, meters, feet, inches, miles. Who knows? So I'm thinking 27, whatever it is. And now I'm going to go ahead and do the 5x plus 2 and see if I get the same answer. It's not 5 times 6. I just saw that, but x equals 5. So 5 times 5. And then plus 2. Yep, I can already tell it's going to work out. Okay. So
I'm having issues with mine.
number 7?
Yeah.
All right, so give me 1 second. Okay, I am going to change this up for a moment. All right. Let me just share this. And now I'm going to, so give me a second. I'm going to dig in and see what your question looks like. So just give me a second. All right, so I'm assuming yours looks like 7x minus 5 and 4x plus 7. Is that the question? Alyssa?
No.
Does yours have
it's 14 minus 8x equals 20.
You're on number 8? Yeah, I was on number, girl, I thought you were on 7. Okay, so yours says 14 minus 8. Oh, this is why it's difficult. This is probably why it's difficult. I know exactly why. So yours says 14 minus 8x, and that equals, I'm assuming it's going to equal 20 minus 7x, correct?
Yeah.
So you have a few options here, and this is where I was trying to do the best I could to review algebra at the beginning of the school year so that hopefully we could eliminate as many of these issues as we could. So you have a few options here. I'm thinking right now, remember how I always took the smaller value of x and I moved it to the bigger value? Like sometimes I went this way with the x, right? Like a minus 5 to this side, right? Sometimes I did the other way. Sometimes I would do this way, where I see a 13 and a 14. I always took the smaller number and I always moved it to the other side by doing like the opposite. Positive 13 is smaller than positive 14. So I subtracted the 13x, and I kept my value to be positive. If you think for a moment, if I would have subtracted 14 take away from 13 gives me a negative 1x. Do you see how I'm dealing with negatives now? It doesn't really matter which way you go. What matters is the answer at the very end, okay? And it will be the same. Doesn't matter which way you go with that. It's just if you subtract the bigger number to the smaller number, you're working with negatives, and it just kind of creates more work for you at the end. And the possibilities of more mistakes because you're dealing with negatives. However, if you start by moving the smaller x value to the bigger x value, you will always end up with a positive variable. Even if your answer later might be negative, it doesn't matter, but the variable you're working with is positive. So I'm thinking right now, Miss Alyssa, as you're working with this one, I'm thinking you may not have moved the smaller x value over and you dealt with negatives, and that can cause some mistakes in your algebra. So here's my question, and this is where it gets very, very, very tricky. This is your question 8. If you have a negative, so I see this as not minus 8x. I see it almost as if you're adding a negative 8x. Okay, I see this as a negative 8, and I see that as a negative 7. So between negative 8 and negative 7, which one is actually less or smaller?
7.
So 7 is a smaller number than 8, but negative 8 is smaller than negative 7. So thinking for a moment, let's have 0, 3, and 5. So out of 3 and 5, which one is smaller? Obviously 3, right? Yeah. So by definition of this, okay, is not that 3 is necessarily closer to 0, but 3 is to the left of 5 on the number line. Does that make sense?
Yeah.
So if I think if I go past 0, right, what's past 0? Negative 1, so on and so forth, right? So what's going to happen on a number line is negative 8 is to the left of negative 7 on the number line. Therefore, negative 8 would be considered the smaller number. Does that kind of make sense why the minus 8 is actually smaller than the minus 7? Even though 8 is a bigger number by itself than 7, okay, we call that like the absolute value of 8 is actually bigger than the absolute value of 7. However, they gave us a minus and a minus. So you've got to consider the minus there. So the fact that it's a minus 8 and a minus 7, if I was to, so I'm assuming if you add 7 to both sides, if I add 7 to negative 8, I end up with negative 1. But if you do this strategy like I said, and I know it's difficult because of negatives, and that's why I try to avoid negatives, but if I add the negative 8 to negative 7, you end up with positive 1 now. So now when I solve for this, I'm actually going to get a weird, nasty negative number. I get a negative 7. Okay? So even though the x value is negative, that's okay. What I'm assuming now is if I was to plug in this negative into this, if I have 14 minus 8x, but it's a negative 7 here, whoops. So I'm assuming, Alyssa, and I'm looking at this right now, this is going to actually add to a positive number. Why is that? Because we have a minus 8 times a negative 7. Remember, this is not negative 8 minus 7. This is a negative 8, but it's being multiplied by x, where that x is a negative number. Therefore, you're multiplying a negative to a negative because, right, order of operations, PEMDAS, right? PEMDAS tells us to do the multiplication part first. I'm going to show you, I just thought of a little cool trick you can probably do, Alyssa, to help you with a problem like this. So this is weird. If I just look at this, we're doing like algebra here, right? We're doing like algebra 1 stuff here. So if you struggle with algebra 1 with negatives and things like that, there's a good chance you're going to struggle with this content, okay? So I'm going to show you a little trick you can do. if this problem just looks disgusting, Alyssa, I'm going to show you a trick you can do. And if that trick makes sense, awesome. Okay. If it doesn't make sense, then I'm sorry. So do you feel like you want me to show you the little trick that I'm thinking of? Basically, it's like to get rid of the negatives, okay, using like legal math moves. Okay, so watch what I do here, and it's going to look weird, but I think at the very end, it's going to make this problem easier. So you have to identify this first, though. You have to identify that it's a weird-looking problem, right? So when I look at this problem from the get-go, I see negatives, right? I see like this -8 and this -7. And also, what do you notice? You notice that the x is now the second term, right? Like it's no longer x in front. Just like this one, no longer x in front. It's like x is in the back, x is in the back. So the reason why they wrote it in the back, okay, is so they could put a minus sign here. It sounds weird, but the reason why they put the x value in the back versus being in the front is because of literally they wrote it back here because of the minus sign. If they would have wrote it in the front, and you can rewrite these problems, you would put a -8x and then +14, so +14. I didn't do anything but just rearrange the problem. Okay, you are allowed to do that as long as you keep all the signs the same. So I know it looks like I changed the sign from a positive to a negative. Okay, but subtraction is literally just the adding of a negative number. Okay, like 3 minus 1 is the same as 3 plus a -1 because the operation is subtraction. So really what we're doing here is writing this like so. Okay, all I did was switch the numbers around, and you're able to do that because technically you're adding the negative here. Okay. Okay, so that's one way to kind of fix it. Okay, here's another way to make this look even better. Wouldn't that be nice if those were positive x values? Right? So you can actually do that. In the mathematical way to do that, there's two ways you can do that. I usually see it as multiply everything by the same thing. Remember in algebra, you can do anything in algebra if you do it to like everything. That's like one of those kind of like, I'm like summarizing like one of the basic kind of rules. But if I basically multiply both sides by a -1, that's kind of like the actual like process. That's kind of like if you just told some math teacher, oh, just blah, 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 they might be like, what? You don't know what you're doing. You don't know the properties of algebra. But if you said, I'm going to multiply the same number to both sides to an algebra problem, that's just one of those rules of algebra. You can always do that. Okay. So in this case, by multiplying by -1, what happens? Positives will turn to a negative. Negatives will be a double negative now, right? And negative times a negative is always a positive. And multiplying by 1 doesn't change the number. You're just multiplying by 1. So multiplying by a -1 doesn't change the number. It just changes the sign. Okay. So by multiplying by -1 and actually dividing by -1 does the same thing. Multiplying or dividing by -1, it will change all your numbers' signs. So positives become negative. Negative becomes positive. Okay. But it doesn't change the actual value. Like an 8's still an 8. It's just now a -8 or whatever. So negative times negative is now a positive 8x. But the negative times the plus 14, the positive 14 becomes a -14. Negative times the -7 makes a positive 7x. And then the negative times the positive 20, right? The plus 20 makes the -20. So how weird is this? We took this -14 8x. Okay. We took this we took this 14 minus 8x and 20 minus 7x. We switched the 8x and 14. We switched the 7x and 20. And all of a sudden now it's 8x minus 14 and 7x minus 20. Like how the heck did we get here? So I know I'm kind of going like way off, but hear me out. If you have trouble with these minus things and the x's being negative, that kind of stuff, there are ways you can learn to work around that using different methods. Okay. And watch what I do here. So I'm going to finish this problem, and I'm hoping, I know for a fact that I should get a -7 as an answer. If not, then I mess something up, or I mess something up there. But I'm pretty sure that's going to be I'm going to get this correct. Let's see what happens. Oh, you know what? That's not -7. What's 14 minus 20? minus 6, right? 6 plus 14 is 20. So this answer is either going to be a positive 6 or a minus 6. And in this case, it's going to be a minus 6. I did that math wrong. Okay. I saw 14. I saw the 20. I thought 14 and 21, but it's actually 20. Because I just did this in my head, and I'm like, oh, it's not going to work out right. So, all right. That rule. So remember, so now the 7 is smaller than the 8 because positive 7 is to the left of positive 8 on a number line. So now it's going to be a positive 1x minus 14 equals at minus 20. Add 14 to both sides, add 14 to both sides. And this is how I get, once again, a negative 6. So, Alyssa, I can't really tell you any other strategies, but they're negatives and do the best you can. The best I can say right now, if your algebra is kind of shaky, I can give you some more practice on this stuff, or you just got to try to learn to deal with negatives. You know, worst case scenario, I know you understand the general process. You'll have a lot of success. You know, maybe not 100%, but now you're at 90%. You know what I mean? So
yeah, those strategies actually help me.
cool.
A little.
So with that, and once again, I'm recording this video, so if you want to kind of review it, you know, you can always review it to kind of practice it. So here's one way to get better at this. If you feel like this process makes sense to you, what I would do between now and the next class meetings, the next couple days, next couple weeks, have this, like, take a problem like 14, like take this exact same problem. Take 14 minus 8x equals to 20 minus 7x, and see if you can practice on your own turning this into 8x minus 14 and positive 7x minus 20. See if you can go through that process on your own. Okay, see if you can actually go through this process and transform that on your own. And what I would probably do shorthand, I'd probably just do this. I'd probably say and I would just switch the order around. Because there's this thing, okay, and it sounds kind of weird. The reason why we just can't switch these, like from an algebra standpoint, the reason why I just can't switch this stuff up, okay, is there's that thing called I'm blanking right now. There's transitive property. Nope. There's I can see it. Commutative property. Nope. Associative property. No, it is commutative property. Associative property is different. Commutative property says with addition and multiplication, the order doesn't matter. 2 times 3 is the same as 3 times 2. Okay, 2 plus 3 is the same as 3 plus 2. However, subtracting stuff and dividing stuff, that doesn't work out, right? 2 divided by 3 is not 3 divided by 2. Same as 2 minus 3 is not 3 minus 2. So the reason why you just can't switch these around, like the reason why just switching them around doesn't mathematically legally work, is because subtracting numbers, okay, you can't just switch them around. However, if you think of 14 minus 8x as 14 plus a negative 8x, which that actually is true, okay? Like this is the same as this. Now you can switch it so the negative goes in front and the positive goes in the back. That was what I was doing with, I think, this one at the beginning, was I made the minus in the front. So once again, 14 minus 8x, that is not 8x minus 14. Those are not the same. Okay? You just can't switch those around. However, if you multiply everything by -1, which is a math rule, then you can, there's all these different little math rules, that happen. I'm not trying to overdo it and confuse you. So what I would suggest is, if you see those minus x's like that, and you might see that on a test, multiply everything by negative, switch the order around, and then solve it. And the fact that you multiply everything by -1, you don't got to do any weird things at the end. It's already answers there for you. All right, so I feel like I'm going too much into it, and I might be confusing you, so I'm going to pull back, and let's go on to the next question. Okay, so that was question 8, and I'm assuming everyone has a similar looking question, okay? But once again, the answer we got was a what, -6? So I would plug in -6 to your problem and make sure you're paying attention to multiplying by negatives. Okay, positive times a negative is a negative answer. Negative times a negative is a positive answer. Okay. So, and I do notice on mine, let me make sure I don't think I'm sharing the right thing. Okay. So that was Alyssa's question. Okay. And your question probably looks very similar. I'm looking at mine and I see 15 minus 5x. And that's going to equal 9 minus 6x. Okay. I am taking some little shortcut there, and I apologize if I move too fast to show that equals that. Hopefully, from what I've shown you, you understand that in a question like this, the information they gave us, we're going to make that assumption and run with it. That that's got the two pieces of information they gave us, they're going to be equal to each other. Okay, we're going to make that assumption and just run with it for time. So just like we did with Alyssa's question, we're going to multiply both sides by that -1. And what we get is a -15 plus 5x is going to equal a -9 plus 6x. I'm going to reorder it so that the 5x minus 15 is going to equal a positive 6x plus minus 9. Okay. So one more time, we did two steps. Okay. The commutative property, that property in algebra that says whatever you multiply to the left side, multiply to the right side. If you do that, it's algebraically legal. Okay, so then positive 15 became negative, the minus 5x became a plus 5x, the positive 9 became a -9, and the minus 6x became a plus 6x. Okay, and then commutative property says we can switch the order around because they're adding. So now it's going to be, instead of -15 plus 5x, it's a positive 5x minus 15. Okay, I kept the signs the same. Same thing here. I put the 6x in front, it's positive, and the -9 and the -9 goes in the back as a subtraction. Okay. I mean, really what's happening is you're adding the negative there. Okay. That's really kind of what's happening. But it's a shortcut. Plus a negative means subtraction. So I'm going to subtract the smaller x to the bigger x. That seems to keep things easy. And I get a -15 is equal to positive 1x minus 9, add the 9. Just like Alyssa, I got a -6 as an answer for x. So they want me to solve for x, I get -6. They want me to solve for AB, and they want me to solve for DE, which are going to be the same answer, the same length. So AB is equal to 15 minus 5x. However, x is going to be equal to a -6. Whoops. So that's going to be equal to 15 minus 5 times -6 makes a positive 30. So I get 45. So I'm assuming this one's going to be 45 as well. So let's double check. 9 minus 6x. However, x is going to be equal. I always say equal, and so x is equal to -6. So that is 9 plus 36. And that it's a positive 45 as well. Okay. All right. So we have -6, 45, and booyah, 100%. Okay, about 7 or 8 minutes left. Let's see what else we got. So this one's kind of cool looking, right? They give us two triangles. They give us two angle measurements, right? One in each, and say find the measure of angle DEF. So we got two triangles. Let's create some space so we can. All right, so the first one, it says triangle ABC is congruent to triangle DEF. Okay, and they say find, we're trying to find the measurement of angle DEF. So let's see what we know. What the heck do we know in this problem? Let's see. The left triangle, we're going to go ahead and, like before, right? Okay, you see how it goes left to right, left to right. I see ABC. We're going to write it like this, A, B, C. And so I'm going to go in this fashion like this. Okay. So if it goes ABC, I'm going to write this DEF. DEF. And then it says angle A is 64. And it says angle F is 56. So you see they're written in different locations. But since these are equal, and I wrote these in the same manner, okay, where it's ABC and DEF, okay, I'm going to go ahead and fill in. If that's 64, that means that's also 64. If that's 56, that means that's 56. So what they want is that missing angle. Well, what do we know about triangles? Okay, the inside angles, the interior angles of triangles always add up to 180. So I can say 64 plus 56 plus this unknown angle is going to add to 180. Just like, right, 64 and 56 plus this missing angle will add up to 180. So I'm going to say 64 plus 56 plus the measure of angle and DEF, right, from DEF, DEF, all right, this degrees, whatever that is, that's going to equal 180 degrees. So combine my like terms, it's going to be 120 degrees plus the measure of angle DEF degrees, and that's going to be equal to 180. Subtract 120, subtract 120. What's left over is the measure of angle DEF is going to be equal to 60 degrees. I guess I don't got to write those little degrees there because it's implied. So that means this would have to be 60. Let me double check that. I feel pretty confident with it. But if I say 64 plus 56 plus 60 is 180 degrees. Cool. All right, where are we at? Let's double check. Let's throw this in here. 0. I feel confident. Bam, got it. Sweet. Okay, I'll keep this up for about 20 more seconds. I'm assuming you guys hopefully kind of did the same thing with me, with your problem, and you got your own answers that make it add up to 180. So I'm assuming with your problems, it's going to be the same thing. You'll be given two triangles with the things all labeled out. They're going to give you maybe two different angle measurements, right? Like in different piece, like they only gave us, right? They only gave us this piece and this piece. However, I know that this is relative to that one, okay? Just like this is relative to that one. Here's someone ask a question or something. Nathan, you can go. Have a great weekend, man. I'll see you next week. Okay, last question. Here we go. Here we go. Let's see. Question 10. We've got two triangles. I'm going to write these a little bit bigger. Let's do, this is a little bit bigger triangle. Let's do this one. Now the triangle I drew out, it's an isosceles triangle, okay? Isosceles triangle is where the two side lengths are the same. I'm just drawing this for reference to give us some more space, but I don't know if those side lengths are the same or not, okay? It's not perfect, okay? Even though it looks nice and pretty, it's not actually like this. I'm just doing this to get a bigger looking triangle. So it says triangle ABC is congruent to triangle DEF. Okay. Once again, the order matters how they wrote this. Okay. They want us to find X. They want us to find the measure of angle CAB. And they want us to find the measure of angle FDE. So I got to double check this, but for right now, I'm not making any assumptions. Okay. I'm just going to draw out what they gave us for information. So just like before, it has ABC. So I'm gonna make this easy for myself and put A, B, C. Okay. Where I start here and go around. So I'm gonna start here and go around. A, B, C, D, E, F. Now what do they give us? They said over here on angle A is 6x minus 9 degrees. So I'm gonna go ahead and just for make it look nice, I'm going to put this. And then over here, it says angle D is 4x plus 5. So here is 4x plus 5. So the last question, we had to add them up to make them equal to 180 because they were different angles. This time around, it's not like that. This time around, they say it's the same angle. Okay, they're telling us that angle A, and if you think about it, look at this. They gave us A and D. Okay, look at that. A and, whoops, and D. It's the first letter, the first letter. That means they're the same. So whatever this is, whatever degree measurement this is, at that vertex point, it's the same thing there. So I'm looking right now, it says CAB and FDE. You notice that the vertex in the middle, A and D, remember that letter they put in the middle? That letter they put in the middle is kind of where the angle is. Okay, so A and D, A and D. So all I want us to do is solve for X, put them equal to each other, solve for X, and then plug that number back in. Now they're going to be the same number, just like we were doing in the past. Okay, so 6x minus 9 equals 4x plus 5. Okay, smaller number to bigger number, smaller number to bigger number. 2x minus 9 equals positive 5. Add 9, 2x equals 14. Divide by 2, and I get x equals to 7. So I'm assuming it's 33 degrees. Okay, I'm going to make a little note here that it's 33 degrees. Let's see if it actually works out that way. 4x plus 5, but x equals to 7 plus 5. It's 28 plus 5. Yeah, got it. Okay, let's try that out. 7 is x, 33 for that measurement, 33 for that measurement. Bam. Got it. Okay, so I'll leave this up for a moment. It is 11:30 on the nose, so you guys are pretty much released right now. I can't really hold you guys any longer than this. If you have any more questions, you can ask them now. And it's just me. Awesome.